keep thinking that I got a minus sign in the wrong spot, so. Because I know what the, do I? Can anybody answer my partial questions?
I think you do have a minus sign in the wrong spot.
Okay.
Don't see any minus signs.
I see them in Dr. Fox's head. I'm mind reading today.
Hey, all right, stay away from the ugly places.
Yeah.
Transformation. That's the nasty version I don't want to do. That is not where we are right now. That's not it either. But whatever is happening right now, we are recording it for all posterity.
Yes. Let's just put this on loop. If you just go through these pages the whole class.
We're on the edge of our seats.
I know.
It's the biggest buildup of all this year. Although I have to admit, coming to the conclusion after all of last class of getting 2.99 times 10 to the 8th was definitely the biggest buildup of the year. You planned that so carefully.
Getting the speed of light, you said?
Yeah.
Yeah,
And we spent the whole class going through and collecting all the little formulas, putting them all in the corners, this and that, and then it was like, and the answer is 3.
Yeah, you're just like, what?
Got it. I'm confused why they're both T prime.
Yeah, I'm hoping to resolve all of that. And I know I saw this yesterday. Well, if you're cringing right now, don't know if you are or not, last night I was really off and it was just absolutely horrible.
Just off your game, or?
Yeah, you know, I'm going to find it like I'm doing now, except I had to do it several times last night.
We're not cringing, we're enjoying the mental break.
If we're edgy, it's just because it's the end of the semester.
I wanted to blow your mind one more time.
I will not be leaving
Yeah,
this
that's a great
classroom
explanation.
until
have
I
way
have
too
an
much
answer.
homework.
Right, I'm just like, I can't even sit
I'll
still.
stay all day.
Is there a calculus version in there? That really bloated that.
I was gonna save that, we will not get to the calculus today,
I don't
unfortunately.
actually think
Oh,
it'll
no.
blow my mind, I think it'll go all the way over my mind. Like,
You're
so
right.
far above my head
It
that I just
won't
won't
even
even
blow.
get it.
You're
Yeah,
right. You're
it won't
right.
even blow because I won't even recognize how awesome it is, right?
All right, I'm going to try that again. All right, so we have some reference right here of 0. This is when x prime is equal to 0, and, that's where x is equal to 0. I want to make sure I'm getting my prime frames right. All right. When the car passes this point, light flashes. So the car is at this point when the light gets to it. So from the car's point of view, the light is this distance away. That's from the car's point of view. This is what we'll call the S prime frame, and then the S frame is what we'll consider the ground for this example. From the ground's point of view, the light is some distance x away. Now, how far the car has traveled in here would be how fast the car is going relative to the ground times how much time has passed from the ground. So this would be VT. That's the proper setup. In other words, x is equal to VT plus x prime. That distance the light So where the light is from the car's point of view, how far the car has traveled relative to the ground, and then how far the light is away from what we consider zero. So x prime is equal to x minus vt. Galilean relativity, this right here is completely legitimate. Physics 151, this would, even though we didn't formalize it like this is legitimate for physics 151. However, we know things are not quite as they seem when we get into if speeds are fast enough. And so this is going to be the hand wave, because I don't want to take you through the 15 minutes to justify it. What we're going to claim here is that the relationship actually between what's happening in the prime frame and what's happening on the ground is a linear relationship, so that there's just some value. This A has no meaning other than the fact that I just needed a letter to put there. So this, from the ground's point of view, times some constant is going to get you the same value for the
Car?
car. Thank you.
We've not have known it to put there.
Yeah, the justification, I'm gonna just hand wave past it. If I looked at it from a point of view from the other way, so I have x prime is equal to some number times x minus vt. X would be that same number, x prime plus vt prime. Just from the other point of view, the speeds are going in other directions. So from the car's point of view, our reference is going behind us, going in the negative direction. Yes, a little bit of a hand wave there. I'm now going to multiply the two things together. So if x prime times x is equal to a squared times x minus vt, x plus vt. Sorry, that should be primed. I'm going to FOIL. So I have x prime plus x vt prime minus vt x prime minus v squared t prime. Let's figure out what these times are. T is how much time it takes for the light basically to travel well, I'm just going to run through it. Question popped into my head. I'm going to ignore that question. I'm going to suppress it. So T prime, I know speed is distance over time. So T would be x over v. Oh, no, sorry. We're talking about light here. So speed is distance over time, so the speed of light is equal to the distance the light's traveling over the time it takes for it to travel. And from the other point of view, it's equal to x prime over t prime. Speed of light's the same for both of them. So t prime is equal to x prime over c, and t is equal to x over c. Plug in for my times here, and I get x prime plus x v x over c.
Sound like a question mark, Dr. Fox.
Making a lot of substitution here. Somewhere I went astray on this one.
We went astray a long time ago,
Yeah. All right.
or like I did at least, very long.
And the rest is just gonna have to wait.
No, again. Start it over.
And in the end, dot, x prime is equal to gamma x minus vt. You have the exact same gamma. X equals gamma x prime plus vt. Right. And then the relationship with time. Time is equal to gamma. I guess T prime is equal to gamma T minus bx over c squared, and t is equal to gamma T prime plus bx over c squared. These are known as the Lorentz transformations. So when Lorentz was spending a lot of time trying to figure out how Maxwell was wrong, where the mistake was, he developed a whole lot of this background information, but wasn't willing to make that last leap. And it took, again, 30 years. Einstein comes along, reinterprets what happened. But Lorentz had already done all of this stuff beforehand, it still applied. And we're gonna leave it at that. The relativity activity, we have actually nothing written down. And then time elapses. So today is the 20th, so we got 420, 25, 27, and 29. So this is the multiple choice test. This is the calculator test. So basically, we've got 2 days to cover 5 chapters.
5?
Oh my.
Yeah.
What?
No?
At least there's a certain point I want to get to with relativity.
Oh my god.
Wait, are we actually covering 5 chapters?
No.
No.
Okay.
No.
Had me worried for a second.
I'm about to give up right there.
I was about to be like,
And we've done everything the state says that we need to do.
because I was gonna say, at the beginning of this semester, you said like last semester we were really rushing at the end, and then you were like, this semester that's not gonna happen because there's like a lot less material to cover.
Yeah, no, but we've covered all the material that we have to cover.
Okay.
It's the,
Woo.
So we don't cover optics at all in this course?
But-
Weird, I was so expecting that.
yeah, sometimes we have time to do something at the end, either quantum or optics. But, no, I think the couple things. One, notes being a mess is part of it, but also those labs that took more than lab period, cut a couple days out. That was it. 3 days we lost there.
Yeah, we've done quite a few. Do we need to know the Lorentz's transformations? Because I'm like halfway writing them down.
Oh, yeah, let me stand in your way more. Yeah, they will come in handy. Because ultimately, we need to get to how do you fit the whole car into a garage? Or what will end up being a 16-foot pole into a 10-foot barn. All right, so what I'm picturing here, Friday, I want to get to a certain place with this. Yeah, I at least want to get to the pole in the barn. And there's still the relativity activity that we'll do potentially Friday, maybe Monday, and then the tests. And if questions come up, then things will adjust as we go. But to be able to ask questions usually requires you being here on time. Or hoping that, I guess, Zach has questions.
Yeah.
So what you're saying is if we're here on time and we have questions about the material leading up to the exam, we may ask them and use class time to go through problems
Yeah.
related to the exam.
I mean, it could have happened today too. I asked if there were any questions. There were no questions from the people who were in here, so started into this.
I do have questions, but they're like on the labs and I wanted to wait till after class.
Okay.
So.
All right. Oh wait, no.
I was gonna say, we're like at 1
I'm
minute.
sorry. Why don't we take a small little break here since I've obviously just done that.
I didn't even know.
I forgot, this is Wednesday.
I
Yeah.
saw that we were at 1:20 and I was like, are we just ending?
Oh yeah.
Oh.
Yeah.
That's
I
why,
totally
that's why I
forgot
didn't say
that.
anything. I was gonna go right back over to physics too.
Yeah.
Keep going.
No, we still got another half hour, so sorry about that. Because I ought to say, if you have questions, but I have a class coming in 10 minutes, and then I realized, no, not 10 minutes. I'm gonna pause this.
Free.
I appreciate that, Bryce.
Yeah, I never complain about free food.
All right, so let's sort of pick this back up where I decided to jump. So this becomes, so x prime x is equal to a squared x prime plus xv, and this is x prime over c minus v times x over c. Again, this is substituting for time, x prime minus v squared x over c, x prime over c. These two middle terms cancel out. I have x prime with everything, and so I can just divide it out. So I end up with 1 is equal to a squared, 1 minus v squared over c squared. So I get 1 over 1 minus v squared over c squared is equal to a squared. And so a is the square root of that, which is just gamma. And gamma shows up one more time. And so we have the Lorentz relationships that were written up there, and I'm gonna write them up again because we're gonna use them in just a moment here. And so we have,
So you're saying gamma is equal to that constant that you just threw in earlier?
yeah, so here I have a squared is 1 over 1 minus b squared over c squared. If I take the square root of both sides, a is the square root of 1 over 1 minus b squared over c squared,
Okay.
which
Is gamma.
is gamma. It's the same gamma as we had before.
Okay.
So we end up with x prime, I forgot the way I had it written before. So x prime is equal to gamma x minus vt. X is equal to gamma x prime plus vt prime. And we can also relate the times. I'm not going to go through that derivation, I'm sorry. And that's going to be gamma t prime
Plus vx over c squared.
okay, plus vx over c squared. I'm just double checking because I'm going off memory before. And then t prime is gamma t minus vx prime over c. Oops. That should be prime there. So this relates two different events happening in two different reference frames of how you can relate the position and time in the two different reference frames. So did I miswrite something?
I just don't have any primes on my x's when I wrote the Lorentz.
Yeah.
I might have left them off. There should be, in parentheses, there should be both primed or unprimed for the x and the t. So I very well might have left the prime off this one.
So if there's t prime in the parentheses, then the x should also be prime.
Yes.
So I have t prime on that fourth one, but you wrote it for the third one. So you just wrote,
Yeah,
you just went through,
he
okay,
switched.
okay, got it. I'm good, thank you.
Yeah, I was confused by that too.
Written in a different order, apparently.
Yeah.
No big deal.
So now, I'm gonna take what I'm gonna call a 16-meter pole. That 16 meters is the proper length of the pole. So LP pole, 16 meters. In other words, that was the measurement, the length of the pole when the pole was at rest, relative to whoever's doing the measurement. I have a 10-meter long barn here. And the pole is going to be traveling, beta is equal to 0.866. So once the left end of the pole, so we have two different reference frames. From the barn's reference frame, this is 0 here. From the pole's reference frame, this is 0 here. So once the pole, the left end of the pole makes it into the barn, I got two doors here on both sides. Those doors will both close instantly. And that's what the barn is going to say is time 0. So I have 3 events. Event 1, left door closes. Event 2, right door closes. In event 3, pole smashes into right door. We're going to look at it first from the barn's point of view, which is the simpler one. So I'm now going to present sort of the moment in place and time. So the left door is going to close at, this is a position and a time, at position of 0 meters, because that's where the left door is, and at time 0 seconds. Actually, let's do nanoseconds, because it'd just be easier. Because the 0 meters here is because the barn's defining that as your reference. And 0 nanoseconds is it saying when the left door closes, that's what I'm calling time 0. The right door closes at a position of 10 meters, because it's 10 meters from where the reference is. And from the barn's point of view, it closes at the exact same time as the left door. This is sort of set. From the barn's point of view, they both close at the exact same time. The pole smashing into the right door, well, it's going to happen at 10 meters. We just need to figure out how much time it's going to take. So from the barn's point of view, how big is the pole? Well, whenever we're doing any relativity problem, we've got to figure out gamma. So if beta is 0.866, what is gamma?
1.99.
Which I'm just going to make 2 for simplicity's sake. So how big is the pole? I'm sitting here in the barn, the pole's coming straight at me.